Hey, welcome everyone. Uh, in this video, I'm going to describe some overview of microcontrollers, some basic concepts of microcontrollers. So I will explain that what is microcontroller and some of its applications, and the three major microcontroller families that are Intel's 8051, Atmel's AVR, microchip PIC. At last, I will explain that how microcontroller communicate with the peripheral devices. The devices like your sensors, your A to D converters, your D2A converters, or any other similar device that you want to interface with your microcontroller. So in this part I will cover the UART and USART, SPI, I2C and CAN protocols. So let's just begin with what is microcontroller. A microcontroller is a small computer built on a single integrated circuit or chip, and it contains the core processor, the memory and the input output peripherals. And memory in the microcontroller is divided into two parts. One is your RAM, which is used during the execution of the code, and other one is the flash memory in which your program code resides. So whenever you burn your program code into your microcontroller, it will go directly into the flash memory of your microcontroller. I guess most of you know what is the basic difference between a microprocessor and a microcontroller. The microprocessor has no on-chip memory and input-output peripherals. So microcontrollers are used everywhere where you want a task to be automated. They are used in your home appliances like your washing machines, your microwave ovens, your air conditioners, your mobile phones, and they are also used in home automation, industrial automation, artificial intelligence, robotics, and some years ago they are not used for high voltage applications like home or industrial automation, where we have to control the high voltages like 220 volt or above 220 volt. Because our generic relays or the electromechanical relays have a disadvantage of producing back EMF that can damage our microcontroller. But as the time passed, the solid state relays come into the picture. The solid state relays means the semiconductor relays in which MOSFETs and FETs are used for controlling the switching operation. And the solid state relays provides the optical isolation that optically isolates the high voltage and microcontroller. So they are preferred over the electromechanical relays. So there are some other applications of microcontrollers. They are also used in satellites, missiles, radars. They are playing a very important role in the technological development. So here is a general environment of microcontroller. Here some input devices are shown and some output devices are shown, like keypad, switches, push buttons, and it is controlling the motors, LEDs, some displays. Here is one example of using the microcontroller. These are it is a LED dot matrix. LED dot matrix are very popular means of displaying information, as it allows both static and animated text and images. Here in LED dot matrix, multiple LEDs are wired together in rows and column structure. In actual, the dot matrix does not know that how to display a character like your LCD. LCD has a on-chip microcontroller to understand the ASCII value that you are giving to your LCD through microcontroller. So LCD understands the ASCII value and display the character. But in LED dot matrix, there is no such microcontroller that can receive directly the ASCII value and display the character. So in the LED dot matrix, we control the LEDs and make the process so faster by using the microcontrollers that it looks like that the characters are moving. I will explain the functioning of LED dot matrix in more detail in some another video. Here is a second example of using the microcontroller in your home appliances like refrigerator. Here microcontroller is used for controlling the different operations of refrigerator. It is getting the temperature from some temperature sensor IC, and by reading the temperature it is controlling your compressor, or it is taking decision that whether to run the compressor or not, depending upon the temperature inside temperature of the refrigerator. It is also used to generate some voices or alarms if the temperature gets high, like in case you have opened the door of a refrigerator for a long time. Or it can display the internal temperature of the refrigerator on some LCD device. Further, you can connect it to some GSM modem device where it can send some SMS alerts to the user. So it can do multiple tasks. Here is another example of using microcontrollers in your home automation. There are some sensors interfaced to the microcontroller like LPG gas sensor, temperature sensor, the infrared sensors, the light sensors, video or image sensor. And by reading this data, the microcontroller will process the input data and control some output operations like sending SMS alerts to the user through GSM, or controlling the lights and fans by using the relays, or generating some alarms, or displaying some values on the LCD display. So here is our first microcontroller, that is Intel's 8051. It is based on a Harvard architecture and CISC instruction set. The 8051 chips are used in a wide variety of control systems, telecom applications, robotics, as well in the automotive industry, and it is one of the most popular general purpose microcontroller that we use today. And here is some basic information about the 8051 microcontroller. It has 8-bit ALU and 16-bit address bus and 8-bit data bus. 4 kilobytes of on-chip program memory, which is 8 kilobytes in 8052, 128 bytes of on-chip RAM, 32 input-output lines, and full duplex UART and 6 interrupt sources. 8051 microcontroller is produced by many manufacturers. Some of them are Atmel, Intel, Philips, which is NXP, and Sharp, Texas Instruments, Maximum, Dallas. Here is a general architecture of the 8051 microcontroller. These are the two most widely used microcontrollers of the 8051 family. One is the 889C52, that is from Atmel, and another is P89V51RD2, which is from NXP Philips. One special feature of P89V51RD2 is X2 mode operation. Normally all the microcontrollers in 8051 microcontrollers, the clock rate is 12 clocks per machine cycle, but by selecting the X2 mode we can reduce it to 6 clocks per machine cycle. So although the 8051 microcontrollers are very popular and they are good, but there are more advanced microcontrollers available from the Atmel AVR. AVR is a RISC microcontroller based on modified Harvard architecture. So it was developed by Atmel in 1996, and it is better than the 8051 microcontroller in many aspects. Uh, Firstly, in the 8051 microcontroller, you cannot set your input output pins um, easily. In 8051 microcontroller, if you are giving a high logic to any pin, you are simply declaring it as input pin, or if you are giving a logic 0 to any pin, you are declaring it as output pin. But in the AVR microcontrollers, there is some special resistors to control the direction of the input output pins, and for giving the output value and reading the input value, there are two different resistors, so it makes the operation easy. And also, most instructions in the AVR microcontrollers take just 1 or 2 clock cycles, which makes the AVR microcontrollers fast among the present 8-bit microcontrollers. Here is some features of the AVR microcontrollers: that it has a internal power on reset circuit, internal calibrated oscillators, on chip RAM, flash, EEPROM or non-volatile memory, and some resistors on chip, A to D converter, D to A converter, analog comparator, compatible with the SPI, USART and I2C protocols, CAN protocol, and it also supports the JTAG. It is the architecture of the Atmel AVR. The AVR has a orthogonal instruction set. Orthogonal means that all the instructions can use all the addressing modes. We can apply any operation on any register using any addressing mode. These are the families of AVR: Tiny AVR, Mega AVR and X Mega AVR. So here is the third major microcontroller, that is PIC microcontroller. PIC stands for the peripheral interface controllers or programmable interface controllers. These are produced by the microchip technology. These are also based on the Howard architecture and RISC instruction set, and it also supports the orthogonal instruction set. Like Atmel's AVR, the PIC microcontroller also has separate resistors for controlling the direction of input-output ports and giving the values at the output or reading the input values. Here are some important features of the PIC microcontrollers, which are very similar to the Atmel's AVR. That is the architecture of PIC microcontroller. It is a little bit different from the other microcontrollers that are available today. Here, instead of the accumulator resistor, the W resistor is used. The difference between the accumulator and the W resistor is its position. It is positioned in a different way than the accumulator. In other microcontrollers, accumulator is placed at the output of the ALU, so the result of ALU is always stored into the accumulator. However, in PIC microcontrollers, we can store the result either in W resistor or in any other resistor of the data memory. Also, the arrangement of stack memory is different in PIC microcontrollers. Here, stack is not a part of data memory or your RAM. Stack memory has its own independent space, therefore it has some finite size, and this finite size of stack memory depends upon the different PIC models that are available. One another different feature of PIC is that they do not have the stack pointer register, as it is commonly available in most microcontrollers. PIC microcontrollers and AVR microcontrollers use the pipelining technique for the execution of instructions. In pipelining technique, the next instruction is fetched during the current instruction is being executed, so it makes the operation faster. These are some families of the PIC microcontrollers. They are divided into three categories: the low-end microcontrollers, medium-end microcontrollers, and the high-end microcontrollers. They can also be classified as in the form of series, like PIC 10 series, PIC 12, PIC 16, PIC 18, advanced PIC 18, PIC 24, PIC 32. These are the PIC 24 and PIC 32 series available from the microchip technology. The PIC 32 is a very advanced microcontroller. It has a 5-stage pipeline process, and the operating frequency is 40 MHz to 200 MHz, and supports cryptography, audio and graphic interface. In some applications, they are used with the RTOS, real-time operating systems. So it is the second part of this presentation, and in this I will explain that how the microcontroller communicate with peripherals. So as you can see in this picture, here the microcontroller 889C52 is interfaced with the LCD, which is 20x4. It means that it has 4 lines and it can display 20 characters in each line. Here the LCD is interfaced with microcontroller by connecting the 8 data lines and 3 control lines, which is register, select, read and write, and enable pin. So A to D converters and D to A converters are also interfaced with the microcontroller in this way, like by connecting all the data pins with the microcontroller. But in today's market, the A to Ds are available like 32-bit ADCs and 48-bit ADCs. So we cannot connect these ADCs with the microcontroller by connecting all the data pins. That's why some protocols are introduced to reduce the pin count. So our first microcontrollers, 8051 microcontrollers, has one serial communication channel, that is UART, Universal Asynchronous Receiver and Transmitter. As communication is not synchronous, the receiver and transmitter operate at same speed or same baud rate, and the data byte is framed between the start and stop bits to indicate the start of data byte and end of data byte. And you cannot connect more than 2 channels on the UART bus if we want a secure transmission. And the another is the USART, which it means that Universal Synchronous Asynchronous Receiver Transmitter. It supports the both synchronous and asynchronous operation. Here is another protocol, SPI, Serial Peripheral Interface, used for interfacing the peripheral devices, as I described, the ADCs, DACs, or any other sensors. In SPI protocol, the communication can be either between 2 devices or it can be between multiple devices, like one is master and others are slave. Generally, microcontroller act as a master. It uses 4 wires for its communication and has a separate clock and data lines along with the select line. With the help of select line, the microcontroller chooses the device to which it wants to communicate. Prior to the invention of SPI and I2C protocols, the engineers were generally using RS-232 communication. But in RS-232, the TX and RX pins are not synchronized with the same clock. However, they use start and stop bits and same baud rate on both sides to achieve some synchronization. But our modern protocols like SPI and I2C use separate data lines and clock signals to achieve better synchronization. So the SPI protocol has 4 pins. SCLK pin is used for clock, and the clock is always controlled by the master, and the MOSI means the master out slave in, MISO means the master in slave out, and SS for selecting the slave to which the microcontroller wants to communicate. So in the SPI protocol, this is the some disadvantage of this protocol, that if you have number of slaves, you have to increase the select lines. So it will also increase the pin count. This disadvantage of the SPI protocol is overcome in the I2C protocol. So I2C was originally developed by the Philips Semiconductor. In contrast to the SPI, I2C requires only 2 wires or 2 lines for its operation, and it also supports the multi-master mode. It means that there can be multiple masters on the same bus. In I2C protocol, the devices are identified as either master or slave, or most of the times master is microcontroller and slave are the other devices like your ADCs and DACs. The master is a device which starts the data transfer and generates clock signals for the transfer. We can connect several masters as it supports the multi-master mode. So I2C protocol uses the 2 lines for its operation, that is SDA serial data pin and SCL serial clock pin. And these both pins are open drain lines. You have to connect a pull-up resistance for using the I2C protocol. Here is the frame format of I2C protocol when master is writing to slave or when slave is writing to the master. Here every frame is sandwiched between the start and stop conditions. Firstly, start condition and the 7-bit slave address plus the read write bit, then acknowledgement, then the command byte, then acknowledgement, data byte, acknowledgement, and the stop condition. You can read the I2C tutorial in more detail on our website. So here comes the CAN protocol, the controller area network. The CAN originally started by the Robert Bosch. It is a peer-to-peer network. It means that there is no master in the CAN network. Every node has an access to read and write data on the CAN bus. When an individual node is ready to transmit the data, it checks that if the bus is busy or not, and if the bus is not busy, then it simply writes the CAN frame into the network. And if the multiple nodes are trying to transmit a message on the CAN bus at the same time, the node with the highest priority automatically gets the bus access. And the CAN frames that are transmitted in the CAN bus does not contain the address of either the transmitting node or the receiving node. instead of the any address, an arbitration ID is used. All the nodes on the CAN network can receive the frame, and depending on the arbitration ID of the transmitted frame, each CAN node on the network decides whether to accept the frame or not. So understanding this protocol is little bit difficult from the other like USART and SPI and I2C. Another thing about CAN is that it supports two message frame formats, and the difference between the two message frame formats is the length of the identifier. The first CAN frame is a standard frame, also known as CAN 2.0A, and it has a length of 11 bits for the identifier. And second is the CAN extended frame, also known as CAN 2.0, which has a length of 29 bits for the identifier. So here you can see that how different CAN nodes are connected on the CAN bus. And it is the frame format for the controller area network. Here are some companies that manufacture microcontroller. The famous companies like Atmel, Freescale, Intel, Panasonic, Dallas Semiconductor, Microchip, Analog Devices, and the Texas Instruments, ST Microelectronics. Thanks for watching the video. You can comment if you have any question.